Hello everyone, welcome to Aero Mechanology channel. Today's topic is grounding and bonding. Grounding and bonding are critical electrical practices used to ensure the safety and functionality of electrical systems. While both terms are often used interchangeably, they serve different purposes in electrical installations. Here's a breakdown of the differences between the two. First, let's talk about grounding. Grounding refers to the practice of connecting an electrical system to the earth or ground. The primary purpose of grounding is to provide a path for excess current to safely dissipate into the ground in case of a fault, such as a short circuit or lightning strike. This prevents dangerous voltages from building up and ensures that the electrical system remains safe for users. The function of grounding is to protect people and equipment from electrical shock and damage by diverting excess electricity safely to the earth. The purpose is to prevent electric shock by keeping non-current carrying parts, like metal enclosures, at earth potential. It also protects electrical equipment from surges, such as lightning strikes or power surges, by providing a low resistance path to ground. Additionally, it stabilizes the voltage levels in the system by ensuring that any excess current flows into the ground. Now, let's look at some examples of grounding. Example 1. In a home electrical system, the neutral wire is typically connected to the ground at the main service panel. If there's a fault, such as a short circuit, the current is safely carried to the ground, preventing a dangerous buildup of voltage and protecting people and property. Example 2. In an electrical panel, the neutral bus is grounded to the earth through a ground rod. This ensures that if there is a fault, excess electricity is diverted into the ground. Bonding refers to the process of connecting two or more conductive objects, such as metal enclosures or different parts of an electrical system, together to ensure they have the same electrical potential. Bonding helps prevent dangerous voltage differences between conductive parts, which could otherwise lead to electrical shock or equipment damage. It ensures all metal parts within the system are at the same electrical potential, eliminating the risk of a potential difference between two metal parts. The purpose of bonding is to prevent dangerous voltage differentials that could cause shock hazards between metallic parts. It provides a continuous low resistance path for fault current to return to the source, ensuring the protective devices, like circuit breakers, trip properly during faults. Ultimately, bonding ensures safety by keeping all exposed metal parts at the same voltage, typically ground voltage. Example of bonding. In an industrial facility, all metal enclosures, such as equipment cabinets, conduit, and metal structures, are bonded together using bonding conductors. This ensures that if any metal part becomes energized due to a fault, the potential difference between metal parts is minimized, reducing the risk of shock and ensuring the fault current flows back to the electrical source to trip the breaker. Inside the same electrical panel, the metal enclosure is bonded to the ground bus. This ensures that the panel's metal parts do not become energized to a dangerous voltage during a fault. It also ensures that all metal enclosures, like conduit and junction boxes are at the same potential, preventing shock. Grounding provides a path to safely dissipate excess electricity into the ground, protecting people and equipment from electrical faults. Bonding ensures that all conductive parts in an electrical system remain at the same potential, preventing dangerous voltage differences and shock hazards. Both practices work together to ensure electrical safety in homes, industrial installations, and other electrical systems. Thanks for watching. Please like, share, and subscribe. Happy learning.